Okay, so here's the equation of an ellipse. They say then find the endpoints of the minor and major axis for the graph of this ellipse. It's kind of weird, starts out with then. I'm not sure why there's a then there. But anyway, they want me to find the endpoints of the major and minor axis. So, all right, so really what we need on this one is a graph. They don't say we have to graph, but it'll totally help us out. So let's do that. I'm going to roll down here a little bit and graph it. So x is, well, actually, I think I can graph it for us right here. So we're talking about an axis system like this one. And whatever's underneath x, 3 squared. So this graph goes right and left, 3, negative 3. And the graph, whatever's underneath y, that's 6 squared, goes up and down 6. So it goes up to 6 and down to negative 6. And then we just draw our egg shape. I didn't draw it too well. It's probably a little taller. It should be taller than that. Okay, so let's find the points they're asking for. So they are asking for the maximum point on the major axis. Now, what do they mean by the major axis? And down here they're going to talk about the minor axis. So the major is the bigger, right? So this is the major axis. Because this ellipse is taller than it is wide. Now, if you had an ellipse that went the other way, if you had an ellipse that was wider than it is tall, then the sideways, the x-axis would be your major axis. So it's just whichever one's bigger. So our ellipse had a bigger number under y. It's 6 squared, 36, than it did under x. So it's taller than it is wide. So the major axis for us is the up and down. So they want the maximum point. That'd be this point up there. That's the point over 0 up 6. And then they want the minimum. That'd be this point down here. That's over 0 down 6 for that point. And beyond that, they want the maximum point on the minor axis. So that would be right here. That's the point over 3 up 0. And then the minimum point on the minor. So here I could drill that in. That is the minor axis. If you had one that was wider than it is tall, then the minor axis would be the other one. So the minor is just the smaller axis, and the major is the bigger. So the minimum point on the minor axis be this point over here. Back 3. It's minimum. It's lower, right? Minus 3 is lower than positive 3, like minus 6 is lower than positive 6. That's what they mean by minimum or maximum. Now they want us to find something else. They want us to find the focal point. Okay, now for an ellipse, the focal point is always. In fact, let me back up here. Let me come down here and just go over here. So the focal points always are on the major axis, the bigger direction. So they're always on the major axis. So in our case, the major axis is the up-down. In other words, the direction's bigger, the major. So that means we're going to have a focal point about right here, and we're going to have a focus point about right there. If your major axis was sideways, you would have your focal points go right and left. So if your ellipse is wider, your focal points go right and left. Our ellipse is taller, so our focal points, our focus points, go up and down. They're always on the bigger direction, the major axis. Okay, but where exactly are they? How do you find them? Well, there's an equation. It's almost like the Pythagorean theorem. Remember the Pythagorean theorem, a squared plus b squared is c squared? Except there's one small change. You make it a minus in the middle. So this is the focal equation. This is how you find where the focus points are. So let's do that. Let's use that thing. Now what's the A and the B? Well, we've already, and remember, A must be bigger than B. A is bigger than B. Why? Because A squared minus B squared, when you subtract them, the A's got to be the bigger one, so you get a positive answer because it's equal to C squared, which is always something positive. Did that sentence make any sense? C squared is always positive, right? Because it's squared. Even if you put a negative number in there and squared it, it's going to be positive, isn't it? So this side's positive, and it's equal to this other side, so the other side has to be positive. And the only way you're going to get this side to be positive is if you put the bigger number in the front. When you subtract two things, the bigger one has to be in front to make it positive. Okay, so my point in all that is, whoops, kind of making a mess here. doing some more of it. So let's go back here. So when you use this equation, a squared minus b squared is c squared, you've got to put the bigger one in the front. Now a lot of people think, oh, the a is always the one under x, or the b is always under y. That's not true. A and b can switch. So which one's a? Remember what it says here? A is the bigger. So a squared and b squared are the numbers under x and y. Let me bring our equation down here. X squared plus y squared, it was 9 and 36. Actually, we wrote it. It's 3 squared and 6 squared. So a squared, so the form of an ellipse equation, this is a squared. Well, actually, it's the other way around, isn't it? This is going to be b squared, and this is going to be a squared. So the general form of an ellipse equation and I'll write they is like this, but they may switch. They may switch. A and B can switch. How do you know which way? Again, the A is the bigger. So the 6 squared is the A. So this is 6 squared minus 3 squared is C squared. That's 36 minus 9 is C squared. That is 27 is C squared. Now, how do you finish solving for C there? You square root it, both sides, right? Square root of 27, take out your calculator. I'm getting 5.196. It goes on and on, but I'm sure that's enough accuracy right there. Now, okay, great, what is that? That's C is how far center to the focus points. That's what that 5.196 is. Just like A and B are how far from the center, right? A and B right here, or how far from the center to the edge. C is how far up there and down there, minus C, to the focal points. So our focal points must be over 0 up. What was that number? 5.196? That's the top one. And the bottom one must be over 0 down. 5.196. Those are our two focal points, which is exactly what they say here. So over 0, the maximum, the one on the top, 0.196. The minimum one, the one on the bottom, 0 minus 5.196. So the way to find the focal points, they always lie in the major axis. So if your ellipse is taller, than it is wide, it'll go up and down. If we had this kind of an ellipse, the focal points would have been right and left, and then you use the focus equation to find it, which is the Pythagorean with a minus in the middle, and you solve for C. We got C right here, and that is how far, C is how far from the center to the focus points. So A, B, and C in these equations are always how far from the center A and B are to the edge, right? And C is to the focal points. And A is always bigger than B when you use these equations.